Welcome students, get ready to solve multiple choice questions of waves section with TPS. So today in this session we are going to solve paper 1 questions regarding waves section. In this section we are going to cover general properties of wave, we are going to cover light, we are going to cover electromagnetic spectrum, we are going to cover last topic of waves, that is sound. So complete waves section we are going to do. So the very first question is, when water waves pass through a gap, they diffract. Means diffraction process is going to occur. The diagram show wavefronts approaching a narrow gap. So obstacle is there and having a narrow gap. This is a narrow gap. Here we have a gap and here we have a gap. In which diagram will the diffraction be least? So dear students, you have to remember one thing. When wavelength is greater than gap size, diffraction will be maximum. Diffraction is maximum. When wavelength is less than gap size, diffraction is least. Diffraction is least. So basically this is a gap size which I am talking here. Here is a gap size. This is a gap size. Then what will be the wavelength? Wavelength is this gap between two wave fronts. These are wave fronts. Gap between two wave fronts. This is wavelength. So we have option C here. This wavelength is smaller than gap size. So C is going to give us least diffraction. Least diffraction also means that less curvature will be there. Less curvature after passing from gap. So moving to next question. An object is placed 30 centimeter in front of a plane mirror. Here I am having a plane mirror. Oh, let me draw a plane mirror. Suppose this is a plane mirror and object is here and it is 30 centimeter from the plane mirror. Image is also going to be 30 centimeter from the plane mirror, behind the plane mirror. So it is 30, not 3. Which statement describes the image of the object? So option A is the image is the same size and 30 centimeter from the object. No, it is 30 centimeter from the plane mirror, or you can say mirror. So this is wrong. B is saying the image is the same size, means if object is having this size, image is also having same size, and is 60 centimeter from the object. Yes, 30 plus 30, it is 60 centimeter from the object. Yeah, this is the right option. Image is smaller. No, not possible. Image will always remain of same size. In plane mirror, image remain of same size. So moving to question number 3. A small object is placed near a converging lens as shown. This is a converging lens. The lens forms an image I. Which statement is correct? Okay. So if you see here, we are having image on this side. So whenever in converging lens, image is formed behind the object. Image is formed behind the object. So dear students, remember, image will be enlarged, magnified. Image will be, you can say, virtual. Image will be upright. So we have to see these options. So A option is saying image I is diminished. No, I am saying it is enlarged. Diminished means small size, not possible. So this option is wrong. Image is inverted. No, it is possible when image is formed on the screen. So image is virtual. Wrong option. Image I is real. No, it is virtual. Inverted means upright. No, all the three options are wrong. So D is the object O is closer to the lens than its principal focus. So D is right here. And one more thing, suppose this is lens and here I am having principal axis. This is the center of lens. Here I am having principal focus. Here I am having principal focus. So object is closer to the lens than its principal focus. So it means that object is somewhere here. This is right. And this is also the application for magnifying glass. Remember this. And magnifying glass says image will be enlarged, virtual and upright. So moving to question number 4. An eclipse of the sun happens when the moon comes between the earth and the sun. So when moon comes between, so earth is here, here we have sun and moon is between these two. Which statement is correct? So you know sun is giving this ultraviolet UV radiations, visible light and infrared radiations. Infrared. So all the three radiations are not going to come to the earth now because moon is in between this. Infrared radiation from the sun disappears before visible and ultraviolet radiation. No, it is not possible before because all waves travel with the speed of light, and that is 3.0 expo 8 meter per second. Ultraviolet radiation from the sun disappears before, no, not possible. Visible light from the sun disappears before ultraviolet radiation, no. D is saying infrared radiation, ultraviolet radiation and visible light from the sun all disappear at the same moment because they are traveling with same speed and sun is emitting these three waves. So this question is actually relating with electromagnetic spectrum. Moving to question 5. A pulse of sound is produced at the bottom of boat. So you can see here, the sound travels through the water and is reflected from a shoal of a fish. The sound reaches the boat again after 1.2 seconds. So wave is going and then it reflects back. So the time is here 1.2 seconds. The speed of the sound in the water is given. So you have to remember such typical values of speed of sound in water, gas, and speed of sound in solids. You have to remember this. How far means distance between the boat, below the bottom of the boat is the shoal of fish. So we have to find this distance. Dear students, we have to find this distance. So echo method is going to be applied because it is reflected. So V is equal to 2D by T. We are going to find distance. So V multiplied by time divided by 2. So it will be 1500 multiplied by 1.2 divided by 2. So it will be somehow, if we calculate it, it will be 900 meter. So B is right option here. The diagram shows a wave. If you see vertical axis first, it is of displacement given in centimeter, and horizontal axis is of distance, it is in centimeter. So wave is given to us. It is a transfer waves. Which row is correct? So we have to tell about the amplitude of the wave in centimeter. Amplitude is going to be in y-axis, that is displacement, and wavelength of the wave is in centimeter. That will be horizontal axis, means x-axis. So distance is going to be there. So amplitude is from mean position, or you can say equilibrium position, to the maximum peak. So here we have maximum peak. This is equilibrium position, or you can say mean position, or you can say rest position. So the distance between these 2 points is 1 centimeter, you can see. So it means C and D are not possible, either A or B. So 1 centimeter is the amplitude. So what will be the wavelength? Wavelength is the distance from one point to another, to the another point, same point which is in same phase, or you can say from one crust to the next consecutive crust. So it is going to be 8 centimeter. 8 centimeter. So B is the right option here. So light travels at a speed of 2 expo 8 meter per second in glass. Glass is solid. In solid, speed is going to be less. Speed of light, it will be less. In the glass, the wavelength of the light is given. Okay, what is the frequency of the light? So simple question, you have to apply wave equation. V is equal to f lambda. 2 multiplied by 10 power 8 is equal to frequency we have to find. Wavelength is given 4 times 10 power minus 7. So frequency is equal to 2 times 8, 10 raised to power 8 divided by 4 expo minus 7. So if you solve this, it becomes 10 power 15, because this is going to add in the power of 10 power 8. So it will be 0.5. So it comes out 5 times 10 power 14. So this is D option. Question number 8. Scott P signals to Scott Q on the other side of a valley by using a mirror to reflect the sun's light. Okay, mirror is here. We have a mirror. So sunlight is incident at this point. Which mirror position allows the sun's light to be reflected to Scott Q? Okay, so here we need the light. So you can use, I think straight mirror will be going to be used. If I am having this as a mirror, this is point of incidence, and light is going to be, here we have a normal by the angle of incidence, and it is going to be somehow like this. I think this works if we have mirror in this vertical situation. If you see, if this is going to be the option, then it will be go somewhere here. This is not possible. Even D is not possible, then it will go somewhere here. Reflection is going to be a different angle. So for question 8, A option is right. So you have to consider angle of incidence and angle of reflection. Moving to question number 9, images formed by the lenses and mirror can either be described as real or as virtual. So which describes real and virtual images of a point object. So remember, for real image is formed on the screen. Image is formed on the screen. Why? Because light rays meet on the screen, whereas in virtual image it is not going to be possible. So A option is saying real images formed when light rays meet. Okay, an image in plane mirror is an example of virtual image. Plane mirror, yes, in plane mirror images are going to be virtual. Yes, it is right. Formed where light rays meet can be projected onto screen. No, virtual image cannot be projected on screen. Formed where light rays appear to diverge. No, it is going to be converge. In diverging lens we have virtual images. So these two are all wrong because diverge they are using. So A is more appropriate. Light rays will meet and plane mirror is having a virtual image. The diagram shows the air molecules in part of a sound wave at particular moment in time. So which statement is not correct? A is saying earlier there was a compression at X. Earlier you can see compression is following the X. So they are right. Later there will be a compression at rarefaction at X. So it is also, you can see here, it is rarefaction. This part of the wave is traveling horizontally across the page. Yes, it is a sound wave, you know, it moves horizontally, means parallel to energy transfer, to the direction of energy transfer. So this is also right, means to and fro basically. This part of the wave is traveling towards the top. No, top is not possible. It is going to be up and down, then it is wrong. So D is not correct. What is the appropriate value of the speed of sound in air at normal temperature? So this is going to be 3. Okay, it's not speed of light, it is speed of sound in air. So it will be 340 or approximately 340. It can be 330, 320 meter per second. So A is appropriate. Question number 12. Which statement is correct about the speed of electromagnetic waves in vacuum? So speed of electromagnetic waves in vacuum. Ultraviolet waves have greater speed. No, greater speed, not visible light. They all have same. All the electromagnetic waves have same speed, that is 3 × 8 meter per second. They follow the speed of light. Infrared is also wrong. D is right. All electromagnetic waves have the same speed. Question 13. Which diagram correctly shows rays passing through a camera lens? Okay, in camera, the lens which is used, you might be familiar that it is going to give you a small image, diminished image, you can say. One thing, and image will be real. One more thing, characteristics of the images you must remember. And this is a ray diagram of one of the lens as well. We discuss this thing when we draw the ray diagrams, and camera lens is one of the application of that. And real image is going to be there, and inverted image is going to be there. So this option is going to be, this is not possible. Here we have magnified image, this is not possible. This is not inverted. Here it is diminished, inverted, and real. So B is right. A sound wave passes through the air in the direction shown. Direction of travel of sound wave is in this direction. How does a particle of air move as the sound passes? So sound is a longitudinal wave. So it moves, particles move to and fro, means parallel to the direction of energy transfer. So move left and right, to and fro means left and right. B is right. A boy is stranded on an island 5 meters from the shore. He shouts for help, but all he can hear in reply is the echo. Echo, V is equal to 2D/T, reflection of sound of his shout from some cliffs. So here we have cliffs, solid hard surface. You can say sound travels at the speed this in the air. So speed is given. What is the time interval between the boy shouting and hearing the echo? So we are not supposed to calculate in the options. We have to form the, you can say in numerical form, we have to give the equation in a numerical form. So time we have to find, it will be 2D/V. So 2 times 500 divided by 340. So do we have this option? Yeah, it is B. B is here right. Moving to next question, which diagram correctly shows a ray of light reflected by a plane mirror. Plane mirror, so reflection is going to occur. And in reflection, you have to remember angle of incidence is equal to angle of reflection. So these two angles are not same, wrong option. This is going to be 40 if you subtract from 90, because here we have a normal. Normal is perpendicular to the plane. This is also going to be 50 then, though both are wrong. Then here we have 90. 90 minus 50 will be 40 degree. D is right option. Simple question. A sound wave travels from point X to point Y. Sound wave travels from here to here. Which diagram represents the movement of the air molecules due to the sound wave? Okay, this question is similar to the one which we have done in previous question. In the region between X and Y. So it is going to be to and fro. It is going to be, you can say, left and right. So D is right here. Okay, which diagram shows how a converging lens is used as a magnifying glass? So I have told you, in magnifying glass, suppose this is a lens. This is principal axis. Here we have F. Here we have principal focus. Two principal focus are mentioned here. So object will be somewhere here. One ray is going to pass like this from the center of the lens every time. One is going to be like this, and then it is going to pass from F. So they are not meeting with each other. So we have to extend in the behind the lens. So like this, we have to extend them. So we have to see such diagram here. So this is not possible. They are meeting. So A is wrong. In B, you can see, yeah, it is possible. I have drawn it correct. This is totally wrong. It should be parallel to the principal axis. And this is also wrong. So B is right. B is exactly right, the one which I have drawn here. Hope so this is clear. Simple straight question. You must know how to draw the ray diagrams. Okay, then we have the speed of sound in air is given. Which row gives typical values of the speed of sound in liquid and in a solid? So you have to remember the speed of sound in liquid, that is somehow approximately 1400, and in a solid that is approximately 6000 meter per second. So you have to remember, so D is somehow the typical value closer to these values. In liquid it is 1500, in solid it is 5000. Okay, now we are on question number 20. Which of the following is a correct example of a transverse wave and of a longitudinal wave? So, dear students, you have to remember that for transverse waves, the example is water wave, ripples in water wave, you can say. And we take the example of the string which is moved up and down. And for longitudinal wave, we take the example of sound. So in this question, B is the right option. You can see transfer waves and ripples on water and longitudinal wave sound. So moving to question number 21, the diagram shows the waves in a ripple tank in which the water in parts P and Q is of different depths. So when there is a case of depth, it means shallow region, shallow or deep region. So how do the wavelengths and the speeds V1, V2 of the waves compare in P and in Q? So you can see here the wavelength is short and here the wavelength is greater. So from here I get the idea that this is deep region and here the region is shallow. If wavelength is smaller here, speed will be smaller, speed will be less in P. If here in deep region wavelength is greater, so it means speed is greater. Speed is greater here. So we have to see the option wavelength and the speed. So wavelength is greater in Q. Yes, it is greater in Q. So these options are not required. and V1 is greater, V1 is not greater, V2 is greater. Yes, D option is right. In that here wavelength is greater in Q and speed is also greater this one V2. So we are done with this question. Now question number 22. When a narrow beam of white light passes through a prism, it produces a spectrum. That spectrum is having a 7 colors. Roy G. Beth. Red, orange, yellow, green, blue, indigo, and violet. So we are having a triangular prism. White light is incident here. When white light is going to be incident, what happens? You draw a normal here. The color which is having the less wavelength, that is violet, it will refract more towards the normal, and red is having greater wavelength, so it refracts less. Its wavelength is greater and violet wavelength is smaller. So again, we are going to have a normal here. Now we are going to less dense medium. Prism is denser, and here we have air, it is less dense. So this ray will bend away from the normal. So violet is having less wavelength, so it bends more away from the normal as compared to. So somehow like this pattern is required. In B, you can see this is not happening. A, this is not happening. In C and D, you have to see. In C and D, yeah, there is a problem. We have red here, violet is here. So they are indicating violet and red. Violet is going to refract more. So this is wrong. D is right. Greater the wavelength, less the refraction. Remember this. So moving to question number 23, the focal length of thin converging lens is 10 centimeter. Focal length is 10 centimeter. It means suppose this is a principal axis. Somewhere here we have a lens, and this is focal length, distance between center and the principal focus. So what is the maximum distance from the lens that the object can be placed so that the lens act as a magnifying glass? So in magnifying glass, you remember object is placed between center of lens and principal focus. So it will be somehow in between this. So maximum distance we need, so it cannot be 10 centimeter, it should be less than this. So we have one option here, that is 5 centimeter. So moving to question number 24. A microphone is connected to an oscilloscope. The diagram shows the trace. Trace means wave on the screen when the microphone receives a pure. So here we have a wave. Which trace can be obtained when a musical instrument produces a note of the same pitch? Same pitch. Pitch means frequency. Pitch is directly proportional to frequency. Same pitch means frequency is not changed. It remain constant. But of different quality. Different quality means there is some distortion might be, or quality is not as smooth as this wave is. So A option we have that this is similar to this, so no change in the quality. If there is a change in quality, might be some distortion will be here. So same frequency, so wave should be like this. Somehow having the same, you can say, number of waves per second. So B seems good. It is having a distortion here. Quality change is occurring here. No quality change is occurring. This is showing that frequency is changed because more cycles are here. So more cycles means more the pitch. So C is wrong. A is not possible. If we see D here, the amplitude is decreasing, and quality is somehow that good quality is there. So we will be having for 24, this B is right option because here we have some quality change. Different quality is here. So moving to next question, 25. A piece of thin card is held against the teeth of a cog wheel. So here we have a cog wheel and these are the teeth. These are the teeth. So when the wheel is turned at high speed, a note is heard. How can the pitch of the note be raised? So uh, there are only one possibility that start moving the wheel, cog wheel fastly. So if this cog wheel will rotate faster, so this card which is attached here, it will be going to create more voice, more sound will be heard. So by pressing the card against the teeth with greater force, no, this is not appropriate. By turning the wheel more quickly, yes, this is going to be possible. By using thicker card, no. By using a wheel with fewer teeth, no. There is one more possibility can be that you increase the number of teeth. Increase number of teeth. But better option is that start rotating it fastly. So only B is right. Moving to question 26. What happened to light as it passes from glass into air? Glass is dense medium, air is less dense medium. So what will be happening here? Change in speed will occur, change in wavelength will occur. So in glass to air, so in air we have speed of light that is 3 × 8 meter per second, and in dense medium it will be less than the speed of light. Speed of light. So we have to see that speed will be greater here in less dense medium. One thing, and if speed is increasing according to V is equal to F lambda, wavelength will also increase. Frequency remain constant. So which option is going to be right? Its wavelength increases because its speed increases. Yeah, D is appropriate here. Question 27. X-rays, visible light, and radio waves are all part of electromagnetic spectrum. What is the correct order of increasing wavelength? So rugby match is very ugly xylophone game. We have to remember the sentence for the order of wavelength. So radio is having highest wavelength as we go from here till gamma, wavelength decreases. So shortest to longest we have to represent. So here we have X-rays and radio is going to be have the longest one. It should be X-rays, then it should be visible light, and then radio. So this pattern we need here. So D is, I think, giving this pattern. D is right. Moving to question 28. The diagram shows waves set up in a rope. Okay, so here we have a rope by a student moving the free end up and down. This is a free end and this is a fixed end. So at a steady rate means at constant speed, or you can say at constant rate. Fixed end, and here we have free end. The distance between this wall and the person where it is a free end is 2 meters. So how many waves are there in 2 meters? From here, if I start, it ends here, it is going to be one wave, then two waves are there. So what is the wavelength of the wave shown? Okay, wavelength is distance between two consecutive points. So it should be one half of this, two waves are there, so 1 meter. What will be the wavelength when the student doubles the frequency? Doubling the frequency means more waves are going to be produced. So what will be the wavelength when the student doubles the frequency at which the free end is moved up and down? So when frequency is increased, wavelength decreases. V divided by F is equal to wavelength. If frequency is increased, wavelength decreases. It becomes half. So wavelength as shown, it should be 1 meter. So two A and B are wrong. and double the frequency. So wavelength will decrease. D is here, right? It is 1 meter. Now the wavelength will decrease. Moving to question 29. In question 29, a ray of light is incident on one side of a rectangular glass block. So the so that the angle of refraction is 40 degree in the glass. So here it is 40 degree, here it is 40 degree, here it is 40 degree, and here again it is 40 degree. So if you see, these all diagrams are correct till here. Till here they all are correct. But which diagram correctly shows a possible path of this ray if the critical angle of the glass is 40 degree? So now little change is going to occur at this end. So we have to decide here what is going to happen. So dear students, if this is 40 degree, what will be this angle? The angle which is here, angle which is here, here, and here. So you have to apply your trigonometry here. If I extend this line and this line, it becomes 90. So this angle will be according to, you can form a triangle here. Sum of all the angles should be 180 degree. So in a triangle, internal angle should be sum of internal angles. So this comes out 50 degree, 50 degree, 50 degree, and this is also 50 degree. And this is angle of incidence. So 50 degree is greater than this 42 degree. It means the angle of incidence is greater than critical angle. And if this happens, it means total internal reflection will occur. Total internal reflection. So A is not right, B is not right. So in C and D, total internal reflection is nothing. So here we have to decide again based on this end that which is going to be the right option. So even if you forget to apply this trigonometry rule, you can remember the property that alternate angles are going to be same. If this angle is 50 degree, this will be 50 as well. But anyhow, now we have to decide what is going to happen at this end. So at this end, it is a good question, by the way. We are going from dense to less dense medium. When we are moving from dense to less dense medium, ray will bend away from the normal. Ray will bend away from the normal. So you can see here it is bending towards the normal and here it is bending away from the normal. So angle will increase. So C option is right. Very good question. Again, I say this is a good question. Question 30. A sonic tape measure is used to measure the length of a room. It measures a time interval of 0.06 second between transmitting a sound pulse and receiving the echo. So reflection is there. The speed of sound in air is given to you. How far the reflecting wall from the tape measure is. So echo method we have to apply. V is equal to 2D by T. And we have to find far means distance. So here we have a wall and sonic tape measure is used. So this is taking how much time to measure the distance, that is 0.06 seconds. So we have to arrange this formula that we have to make the subject as a distance. So distance is equal to with speed multiplied by time divided by 2. So speed is 330 multiplied by 0.06 divided by 2. So we have to calculate this. I have a calculator with me. 330 with is going to be multiplied with 0.06 and I have to divide it with 2. So this is 9.9 meter. So today I was not ready with my calculator, but I thanks to Sarvakar that he has placed the calculator here. So moving to question number 31. So here B is right option. Question 31. A ripple tank is used to demonstrate refraction of plane water waves. Refraction is occurring here. You can see ray is bending. This ray is going here and then it bends like this. It bends away from the normal, you can see. So what we are going to do here, waves in deep water have wavelength of 1.2 centimeter. So this is wavelength and a speed of 9.6 centimeter speed is given. We can find the frequency as well. V divided by wavelength. The wavelength of the waves in shallow water is also given. The wavelength is here also given. What is the speed of the wave in the shallow water? Shallow water. Okay, so wavelength is less. So speed is also going to decrease. It should be less than this 9.6 centimeter per second. So either the A or the B is the right option. We are not going to C, and D option. So what we are going to do, students, frequency will remain same because it is moving from one region to another. Only this is the difference. So we can find frequency here, then we know wavelength here. We will be using this frequency, then we will be using V is equal to F lambda. So F is equal to 9.6 centimeter per second. Be careful regarding the units. Units should be same and it is same. So if you divide this 9.6 divided by 1.2, it is 8 seconds. So frequency is 8 seconds. So V is equal to 8 times 0.8. So you will be getting 6.4 centimeter per second. So A is right option here. We are done with this question 31. Now we are on question 32. A swimming pool is lit by a lamp. Here is a lamp. In the bottom of the pool, the directions of three rays from the lamp are shown. So three rays are there. One is this, second, and this is third. Which of the marked angles in the critical angle for the light? So when there is a critical angle, ray bends along the boundary of two mediums. Along the boundary of two mediums. Or you can say there is an angle of refraction that is 90 degrees. So D is right here. 32 is having here 90 degree and it bends along the boundary of two mediums. This is the boundary and here we have two different mediums. So D is right. Which type of image is produced by a converging lens on a screen? By a converging lens. So you have to remember mostly it is going to be real. It can be inverted on a screen when it is going to be inverted and it can be large, it can be small size, diminished as well. So here we are not going to have the main concern with this. Actually, this can be dependent on this ray diagram. So this is general that image will be real and inverted. So here A option is saying inverted and real. Yes, this is going to be the right option. Moving to question 34. Very important question again. A child plays a note on a trumpet. She then plays a louder note of high pitch. How do amplitude and frequency of the second sound compare with the first? So she plays a louder note of higher pitch. Higher the pitch means higher the frequency. And louder means amplitude is large. Amplitude. Loudness is there. How do amplitude and frequency of the second sound compare with the first? So amplitude is going to be larger, frequency will be larger because pitch is high. So A is right here. Moving to question 35. Little tricky question. A girl standing 150 meter from in front of a tall building. So this is a building here. Here we have a girl, and it is 150 meter from the building. Fires a shot using a starting pistol. A boy standing here. We have a boy standing 350 meter from the girl. Here's two bangs 1 second apart. From this information, what is the speed of sound in air? So two methods are here. One method you can see it is technical and right one. That is when the shot of this pistol is going to be fired, one sound is going to travel like this. And during this, the distance is 350 meter. And one sound is going to travel in this way. It is going towards the building, then reflected from here, and it comes till here. So how much this distance will be? 150. Then it is reflected. It comes here till 150. Then this 350 again. So this distance will be, I name this distance as D2. It will be 150 plus 150 plus 350. So this distance will be 650 meters. This is the distance of reflecting sound, reflecting sound from the building. Reflecting sound is covering 650-meter distance. And the distance covered by sound in straight way, that is 350 meter. So we can take the difference of these two. You know, 650 D2 minus D1 I say is equal to distance. So it will be 650 minus 350. It comes out 300 meter. This is the distance which is having a gap, which is having a gap between two banks. Gap between two banks. This is the distance. And time is taken of 1 second. So you know speed is equal to distance of time. 300 divided by 1, it will be 300 meter per second. And this is one of the appropriate methods. So A is right. If we know speed of sound will be same in air, because here the same air is here, here the same air here. So what we can do, we know we can find the speed of sound which is here, which the girl is also hearing. It will be V is equal to 2D by T, and it will be, 150 going here and coming back to 150. So it will be 2 times of 150 divided by 1. So you will be looking that this will be 300 meter per second. But we are not known about this time. This is just we have taken this one, but it is not appropriate. The best solution is this one, because you know the time, that is 1 second apart between two banks, means one sound is heard by covering a distance of 350 meter, and the another sound which is heard, that is after a covering a distance of 650. Then we take the difference between them, then we will be finding the speed. Little tricky question. So we are done with this. Question 36. In which of the diagrams is the path of light ray not correct? This is correct. It is going from denser to less dense and bending away from the normal. This is correct. See, going straight, because here we have a 90-degree. When angle of incidence is 0, ray passes straight. And here again it is bending away from the normal. In this, it is again passing straight, because here we have a 90-degree and then total internal reflection is occurring. This is also correct. Here it is 90-degree, but ray is bending. It should pass straight, because angle of incidence is 0 here. Because incident ray and normal line, what they are doing, they are overlapping with each other. So angle of incidence is 0. So this is wrong, not correct. D is right option here. A spectrum is formed when white light passes through a prism. In which position are the colors green, red, and yellow? So we know Roy G. Biv. So we are given with green, red, and yellow. So red should be first, then it should be green. Oh, yellow. Then it should be yellow, then it should be green. First, second, and third. So according to this, it will be D option. Red, yellow, and green. So 37 is D. Moving to question 38. The diagram shows waves traveling on the sea. Which points are one wavelength apart? One wavelength. You know, it is distance between two consecutive two consecutive points which are in same phase, same angle, same phase. or you can say distance between two consecutive crust points. So here is 1 point, then the next should be here, but it is not having any point. One is here, it is not having another point. So Q is here, so it is going to be half wavelength, and then it is going to be full wavelength. So Q and T is C option. Question 39. A lens forms a blurred image of an object on a screen because image is in front of the screen. How can the image be made sharp and in focus on the screen? So there are ways that either you move the screen, this is one way. Other way is that you use diverging lens for the correction. If it is a case of short-sighted or long-sighted, then we know that we do correction. So the other way is you can use a lens with larger principal focus or focal length. So we have to opt one option from this category by moving the object away from the lens, not away from the lens. By moving the screen away from the lens, no, not possible. By using, because already image is in front of the screen, why you are moving the screen away? By using a brighter object at the same position, not possible. By using a lens of longer focal length at the same position. So what will be having if focal length is greater? The rays will converge somewhere on the screen. So D is right. Increasing the focal length increases the converging converging power of that lens. An object is placed in front of a diverging lens. Here we have object. As shown on the scale diagram, the principal focus F is marked on each side of the lens. At which position will the image be formed? So it is a diverging lens. We have to draw a ray diagram. One ray should be passing from the center of the lens, and it starts from the tip of the lens. Tip of the lens. So it will be somehow like this. Use a sharp pencil, and one ray is going to go from the tip parallel to the principal axis till the center of the lens, till here. And now it is going to diverge. It is going to diverge based on the principal focus. So here is the principal focus. So it is going to diverge. So, by the other way, we have got the image. So we are done with this ray diagram. So image is formed at point C. Image is formed at point C. You can see here they are intersecting. So C is the right option. So dear students, we are done with this section. We have done 40 questions of waves, and we have covered all the sections. Sound, light, electromagnetic spectrum. We have covered general properties of waves. So hope so it is good for your preparation regarding this section waves, and hope so if you have any doubt or if it is all clear, then it's good. If you have any doubt, any question, you can contact me. Stay blessed. Take care. Thank you.